Hello everyone, thank you for joining us today. Have you ever wondered how to expand Druid to data science? Our company did, and today I'm going to tell you about our solution by answering the question of why and how we've built an open source Spark Druid connector. My name is Beata Wiśniewska, and I am a data engineer at Deep.BI, responsible for developing and integrating AI and BI pipelines with emphasis on open source big data technologies such as Apache Flink, Spark, Kafka, and Druid. I've also co-created Spark Druid Segment Reader. I program with Scala, Java, and Python, and currently studying computer science at Poznań University of Technology. Now let's look at the agenda. At the beginning, I'm going to say a few words about our company, Deep.BI, and how we help our customers use Druid with combination of Flink and AI. Next, I'm going to focus on our idea of expanding Druid to data science. Finally, we will look at Druid Segment Reader, how it works, its advantages, and its current limitations. At the end, I'm going to show you a quick live demo in Jupyter Notebook. Deep.BI has been founded 7 years ago. Our teams manage clusters, both on cloud and on-premise, with over 200 dedicated servers. We are experienced with cluster storing and processing petabytes of data. This roughly translates into billions data rows processed every day. Today, we share our knowledge and experiences with others. At Deep.BI, we support open source Druid in multiple ways. So far, we helped over 50 companies in USA, Latin America, Europe, and Asia, setting up, tuning, and maintaining their Druid-based analytics pipelines. Our clients are large enterprises as well as ambitious startups. They represent different industries, such as banks, telecommunication networks, cybersecurity. We also offer services such as support, expertise, design best practices, manage Druid. At Deep.BI, we work heavily with Druid on a daily basis, and it's a central component of our real-time stack for both analytics and AI use cases. Other key components of our stack include Kafka, Spark, and Cassandra. We also build tools around Druid to enhance its capabilities, for example, predictive cache. We started contributing to Druid, and we plan to increase our efforts here. Now let's focus on expanding Druid to data science. On the screen, we can see a typical streaming analytics pipeline with Druid. Most of you probably saw the similar schema of system architecture where Druid is used. Events are collected through an ingestion service and pushed to Apache Kafka. Apache Flink is used to enrich and pre-aggregate the events. The pre-aggregation involves mostly stream joins, allowing to suppress the need for ad hoc join operations at query time. The processed data is then indexed by Apache Druid for real-time analytics. In most cases, the data is indexed in a non-aggregated manner. All historical data is stored in deep storage. In most cases, we used Ceph with an S3 gateway, but any other compatible storage, such as Amazon S3 or HDFS, can be used. Druid query results are served through integrated systems, allowing the end users to create their own dashboards and reports. Although such an architecture is very flexible and robust, we stumbled across an issue of extracting historical data for more complex processing. Specifically, we wanted to add AI capabilities for our customers. In order to train an AI model, we obviously need a dataset. A dataset built from the raw events collected. Raw events need to be inspected, transformed, and modeled into a data structure suitable for machine learning. This is usually the most essential and time-consuming stage of any AI project. Since the data is stored in Druid, it has to be extracted from there. In such situation, we typically have several options. First, we can extract the data directly from Druid using scan queries. Such an approach works really well, but only for small amounts of data. It quickly becomes an issue when we want to extract terabytes, not megabytes. And it's not only computationally intensive, but it also puts heavy impact on Druid cluster performance. Secondly, we can use Druid Segment Dump tool. Here we can skip both the Druid query and data nodes and read directly from deep storage. The tool is, however, more useful for debugging than extracting the large amount of data. And it's not that trivial to read the result as a data frame in a scalable manner. As the last option, we can always archive a copy of the data as a data frame on HDFS. Unfortunately, this requires duplication of both the storage and the indexing processes. It quickly becomes an operational burden and a significant cost, especially if in most cases we only need this data for a limited period of time. Coming back to our typical streaming analytics architecture, let's see how we can add AI model training and saving capabilities without these additional operational and infrastructure costs. Druid Segment Reader allows reading data directly from deep storage. Data is available as a Spark DataFrame in PySpark. Thanks to such an approach, data scientists are able to run their complex queries on historical data to build datasets used to train AI models. Moreover, not only there is no need to duplicate data, but they can also reduce the amounts of data loaded into Druid historical nodes. After the AI model is trained and evaluated, it's serialized and pushed to Apache Flink for online predictions. Furthermore, the predictions can be evaluated in a similar batch manner as previously. But what are the key benefits of that solution? We can reprocess historical data without Druid cluster involved, and thanks to this, we are able to reduce data duplication by huge margins between data lake and Druid deep storage. Different teams could run ad hoc analysis on all historical data going years back without putting pressure on the Druid cluster. Now we already know why we use Druid Segment Reader, but let's see how exactly it works. Druid Segment Reader is an Apache Spark connector that extends the DataFrame reader. We initially developed the project 5 years ago for internal purposes only, but we decided to slightly refactor it and publish as an open sourced project with Apache 2.0 license. The direct link to project on GitHub will be shown later. This tool allows reading Apache Druid segments directly from deep storage in PySpark. By using the DataSource option, you can easily define the date range of the data source of your interest. As you can see on this simplified diagram here, it is capable of automatically reading the segment schema from the data and converting the data structures into Spark types. Now let's have a look how it works in some more details. Firstly, the connector detects the segments for given intervals based on the directory structure on deep storage. Next, for every interval, only the latest version is loaded. Data schema of a single segment file is inferred automatically. Then all generated schemas are merged into one compatible schema. Schema data types are then converted into Spark data types. So when we already have a compatible Spark schema, we can start to read data row by row. Each row is mapped into new Spark row and schema rendering segments into Spark DataFrame. What certainly distinguishes our connector is the fact that the data schema is inferred automatically, so you don't need to pass it earlier. Schema is generated for every segment file, and then all of them are merged into one compatible schema. It's an important feature when you don't have a strict data schema. In case when the dimensions are automatically detected at the indexing time, each segment can have a different list of dimensions. The parameters of Druid Segment Reader, such as the data source name, start date, and date, are defined through Spark DataSource options. As I will show you in a demo in a moment, such an approach simplifies the process. For a data scientist, it almost feels like reading local files. Currently, our connector has a few limitations. We are able to read only the dimensions, skipping all the metrics. Druid Segment Reader supports only segments with daily granularity, and only the latest interval version can be loaded. But as I mentioned before, it's an open source project, so if you have any particular need to extend the connector, feel free to contact us or do it yourself. Now I'm going to show you how our connector works in Jupyter Notebook. Alright, so if you want to use our Spark Druid Segment Reader in Jupyter Notebook, first you need to load necessary imports such as SQL context, Spark session from PySpark.sql. Then you need to create Spark context with custom jar added. And if you use S3 as your deep storage, you can read the data directly from them. But you need to remember to add endpoint and credentials. The next step is to create read configuration dictionary with required parameters such as Druid data source, start date, end date, and input path. The other important thing is to add the correct format, Druid-segment, and to remember about read options. If everything is correct, we can print the schema and see the result. We can also convert data frame into pandas data frame, which is very useful. Yeah, we can also query. Now we can see it. We can also query the selected data using SQL queries. This effectively allows us directly query Druid, include the intervals not currently loaded on Druid historicals. So, in other words, we can run complex processing on Druid segments without involving the Druid cluster. Now let's go back to our presentation. Yeah. I would like to sum up today's presentation. Using Druid Segment Reader allows us to use deep storage historical data for machine learning. This eliminates duplication between the data lake and deep storage. Our connector allows data scientists to work on ad hoc analysis of data from Druid. Data scientist activities can be performed natively in Spark without the need to know other frameworks. If you are interested in our connector, feel free to download it from GitHub. The link is here on the presentation. I would also want to encourage you to check out other interesting stuff from Deep.BI, such as predictive cache for Druid. It's a tool which helps avoiding cluster load peaks by predicts future queries and prefetches Druid cache. We also offer Druid support plans. So if you are interested in, feel free to contact with us. I would like to end my presentation here. Thanks for joining us today, and if you have any more questions, I would be happy to answer them afterwards. Thank you very much.